In the first part of lesson 5, we're going to do association mining with Excel. Association mining in business is called market basket analysis. It helps us understand consumer behavior by identifying relationships between items that consumers buy. It's similar to correlation, but correlation involves, or multiple correlation, involves a numerical number that, if close to 1, implies a strong linear relationship among quantitative variables, like, for example, GDP and number of electric vehicles sold, 2 quantitative variables. When the data involves strings of characters, like, for example, product names, you can't calculate correlation, but you can calculate probabilities, a variety of different kind of probabilities. And association mining or market basket analysis essentially uses probabilities and ratios of probabilities that we've computed. The construct here is built on this if-then idea. For example, you go to the store to buy bread. Once you're at the store, you go, I need some butter. So if bread, then butter. Bread is the thing you went to the store to get. Butter was the thing that you decided to throw in the cart as well when you had already put the bread in the cart. So the butter is the consequent, the bread is the antecedent. In this Walmart receipt, you see a bunch of stuff listed here, right? Silver ears, Hershey snack mouthwash, goldfish crackers in bulk, whatever that is. I have no idea what that is. LSHBLST, Cove, and then paper towels. So imagine this is just a very small subset of products available at Walmart. Imagine every product that Walmart could sell. There would be a column for each one of those. This is the transaction number right here. So this corresponds to a particular customer. The ones and zeros in the row do not say anything about the quantity. The ones and zeros say that if it's 0, then the customer chose not to put that particular product in the cart and buy it. If it says 1, then that customer bought at least 1. The customer could have bought 10 Coca-Cola bottles and paid for them individually instead of in a pack. They would only be counted as 1. So this 0 and 1 is not quantity. It's either the presence or absence of that product in the cart. Now, when you add up this row, you get the number of unique products that are present in the cart. If there's a bunch of transactions here, say 1 million of them, and I add up column B, that gives me the numbers of times that this particular product was purchased in a given month. The average of that column would give me the probability of customers selecting and purchasing that product. So what we're doing here is we're using probabilities. We can count names of products. Names of products are strings of characters. We can count them. And then we divide the count of product X and divide it by the number of transactions in a given period, like a month. That would give us the marginal probability. We can also count the number of transactions where X and Y were present in transactions. This is the joint probability. If we divide that by this marginal probability, we get a conditional probability. This is the probability that Y is purchased given that X was purchased. That's called a conditional probability. In market basket analysis, it's known as the confidence of Y. We got this conditional probability by dividing by the probability of X. But there's another good involved in this calculation, Y. If we, in addition to divide this joint probability by the probability of X, we also divide it by the probability of Y, we get a number that can range from 0 to infinity. Like, for example, this conditional probability were 0.99, and this probability were, say, 0.000000000001, this would be a very large number. This has to range from 0 to 1. This has to range from 0 to 1. So if this is close to 1, and this is extremely close to 0, dividing by 0 gives you infinity. So theoretically, this goes from infinity to 0. It goes to 0 because this could be 0 here, right? And it could be infinity because this could be 0 as well. So with this being 0, the lift would be 0. With this being 0, this would be infinity. It'd be undefined. Now, here's the really key idea here. Imagine this is the equal sign and ignore everything to the left. Probability of y given x equal probability of y. If that is true, then x and y are independent. There's no association. Dividing both sides by the probability of y would result in this being equal to 1. So when this thing here equals this thing here, their ratio is 1. And that's why we say here x and y are not associated with each other if the lift of x and y equals 1. Now, if this is smaller than that, then their ratio would be smaller than 1. And we would say that x and y are negatively associated. If probability of y given x is bigger than the probability of y, then the lift would be greater than 1, and we would say x and y are positively associated. When you're on either one of these websites and you've purchased a product or you streamed a movie, then when the movie's over, you're going to see a queue of movies. So if a lot of people liked and watched the movie that you had just finished watching, what Netflix wants to do is they want to keep you on Netflix. So what they're going to do is they're going to put movies in your queue that you haven't watched yet that other people have watched and liked, and those other people viewed the movie you just viewed. So these all have positive associations with the movie you just watched. These lifts might be, from left to right, this lift might be the highest, this lift might be the lowest, right? So Netflix does that. It uses this association mining or market basket analysis. When you buy something on Amazon, you'll get a list of products that other people purchased while purchasing the product you just purchased. And again, they probably use a form of association mining. I suspect this might have the highest lift. And of these that are shown, this might have the lowest lift. And then McDonald's has done this for years. When it sells G-value meals, it noticed that when people came in to buy a Big Mac, they threw in a Coke and a fry. So what McDonald's does is they make it easy for you to make those three purchases together. And the reason why they want to do that is because maybe the sandwich has a very small markup. I mean, this is the most expensive thing to produce, right? The sandwich. The fries, the cost of making fries is really small. The marginal cost of an additional Coke is tiny, which is why in most McDonald's restaurants in the United States, all sizes are $1, right? Or that used to be the case, right? You walk in McDonald's, you can get a large for $1, you get a small for $1, get a medium for $1, right? What that says is the marginal cost of a soda is really close to 0. The margin on the Coca-Cola is not 0, right? So what they do is they bundle these together so that you purchase a Coke at a discount, but even at that discount, they have a massive markup on it. So the markup here is incredible. Now, what we're going to do before we proceed is we're going to download this file. I want to name it lesson_unit 5, and then use your last name there. Now, the data here is not the data we're going to use to answer these questions, nor is this data the data we're going to use. To get the correct data for this problem, you need to scroll to the bottom of this problem and grab it from the table. Everybody's going to have a different data set. Everybody has different answers. What I'm going to do is I'm going to copy this. I'm going to paste it in cell A1 as match destination formatting. Now make sure Quarter Pounder lines up with QP, Big Mac lines up with BM, et cetera, et cetera. I'm going to format the transaction number with no decimal places. This is just the transaction number. It's the number that's printed on the receipt. Randomly selected these transactions from all the transactions at this McDonald's. And then we sorted them on transaction number, right? QP again is Quarter Pounder, BM is Big Mac, et cetera, et cetera. Before we move on, I want to name the ones and zeros below each set of initials. I'm going to use that for the name of these ones and zeros down here. I'm going to do that for all of these columns. And the way to do that is to go to the Formulas tab and then click on Create from Selection. Make sure the top row is selected because we're going to use these as the names of these columns. And then I'm going to insert a bunch of rows above to do the work here. When I type equal QP, you can see that that set of Excel cells, that Excel object has been named QP. Okay, so now that spreadsheet is all set up. Then the next thing I'm going to do is I'm going to copy it to the completed table. So I'm going to click on the 0, hold down Shift Control, the down arrow and the right arrow. I'm going to copy the data and paste it right here. Okay, so change the data slightly, right? Okay, so now we're ready to start answering questions here. So chicken nuggets are the antecedent. You go to the McDonald's to buy chicken nuggets. You have a craving for chicken nuggets. So the consequent here is the chocolate shake. Ante means before, consequent is like a result of something, right? So you go there to get the chicken nuggets. While you're there, you go, throw in a chocolate shake too, right? So this is our A, event A, and this is our event C. And we want to calculate the probability of A. And that is called the support of A. We also want the support of C, the consequent. And that's the probability of C. And then we need the probability of C and A. I'm going to use a little lowercase n there for and. This is just called the support. In market basket analysis or machine or association mining, when you see the word support by itself, you're talking about both the antecedent and the consequent. You're talking about their joint probability. And then we need the probability of C given A. And then we need the probability of C given A divided by the probability of C. So now we need to calculate the probability of A. And A is chicken nuggets, right? So I'm going to highlight CN and all the ones and zeros below it red. I'm going to do the same thing for chocolate shake. So this is chicken nuggets, and this is chocolate shake. Now, to get the probability of A, one thing we can do is we just count the ones, right? We can count the ones. That's going to take a while if this is more than 50. If this is 1 million rows of data, we don't want to count them, right? Another way to do that is we could just use the command count. We could use the command count. Well, the command count if, right? We could use equal count if, and then type CN, right? Type CN there, see? And then we need comma, then quotation marks equal 1, close quotation marks, and then press enter. And this will count the stuff in the object CN if it equals 1. It's 18. That's pretty complicated, right? That's the frequency of A. That's the frequency of chicken nuggets purchased in this set of randomly drawn transactions, right? 50 transactions. That's kind of complicated. If we use sum instead, what is sum going to do? Sum is going to add ones and zeros together. When you add ones and zeros together, sums of zeros is 0. Sums of 1 is the count. So that's probably a better thing to do, right? So there's 18. 18 ones and zeros. We don't want the frequency, we want the relative frequency. And we're going to interpret that as a probability, right? So if we take the sum of this object named chicken nuggets or CN, and we divide it by the count of, let's say, transaction number, we're going to get an error message here because I haven't named this set of cells yet. So I'm going to highlight just the numbers, and then I'm going to come up here and name this TN for transaction numbers, right? Transaction numbers. Now, when I do that, I get a 0.36. So we're summing ones and zeros, and we're dividing by, I think, 50 here, right? We had 50 transactions. Another name for this ratio is just the average. The average of the ones and zeros, this object named CN. So the marginal probability or support of A is 0.36. So our antecedent is chicken nuggets. Our support for the antecedent is 0.3600. The probability of the antecedent is 0.3600. Now, what about the consequent? Chocolate shake, right? So we're going to average this object highlighted in blue here. We're going to average the items in that object that we've named CS. We're going to average that, and we get 0.16. So chocolate shakes is the consequent. The support for the consequent is 0.1600. And the probability of the consequent, 0.1600. I needed chocolate shakes. Sorry, chocolate shakes. Now we can calculate the joint probability of C and A. We want the probability that C happens and A happens, right? Now, the way to do that is we got to widen this up first. In this transaction, the person bought chicken nuggets, but not a chocolate shake. In this transaction, the person did not buy chicken nuggets and did not buy a chocolate shake. In this transaction, the person purchased chicken nuggets and a chocolate shake. And notice when I multiply 1 by 0, I get 0. When I multiply 0 times 0, I get 0. But when I multiply 1 by 1, I get 1. So what we want to do here is we want to multiply these items, these ones and zeros together, row by row, and then sum that. And there's an Excel function for that. It's called sum product. So the first thing I want to do is I want to put in the CN column, right? Chicken nugget column. And then I want to put in the CS column, chocolate shake column. And this is going to give me the number of times one shows up simultaneously in these two columns. There's 4. There's one of them. There's the second one, the third one, and the fourth one. So 4 times out of 50 do people buy both chicken nuggets and a chocolate shake. Now, this is the frequency, right? So we have to divide this by the sample size, the count of TN. And we get a support. We get a support of 0.08. The probability of C and A. The conditional probability is the joint probability divided by a marginal probability. In this case, A. This is the conditional probability, 0.2222. And then what we want to do is we want to further divide that by the other marginal probability. So we've already divided C and A by the probability of A. Now we need to divide it by the probability of C. And we get 1.3889. Now your numbers are going to be different than mine, right? So this last item here is not a probability. It's not between 0 and 1. The support, as I mentioned above, is that. The confidence is the conditional probability. Confidence, conditional probability. Confidence, conditional. And then the lift is the joint probability divided by the product of marginal probabilities. That's another way to do it. Now, because the lift is positive, greater than 1, if this were 1, if the lift equaled 1, if this were 1 here, then this and that would be equal. But that's not the case. Now, because it's bigger than 1, we say what? Positively associated. So given my random sample of 50 transactions from McDonald's, in my random sample, chicken nuggets and chicken chocolate shakes are positively associated. You might get something else, right? In part 2, we're going to consider a person who walks into McDonald's and orders a large Big Mac meal. So in that Big Mac meal, they're buying a Big Mac, they're buying a Coke, and they're buying fries. But the Coke is large, and so are the fries. So that is the antecedent. The purpose of this visit was to purchase these 3 items. Now we want the support of the antecedent. So I'm going to insert some rows here. I'm going to copy this. I'm going to paste it down here. Okay, so now the antecedent is what? Big Mac and large fries and large Coke. That's the antecedent. Now, the person then, after they made that order, they decide, I want some dessert. Consequent is going to be dessert. It can be one of those. We'll put it right there. So this is what they went in to purchase, the Big Mac value meal. And then they decide to add one of these on, right? Dessert, after ordering the Big Mac meal. Let me delete these. The support for the antecedent is what? Well, let us change the coloring down here. Let us change the coloring. We're going to reset it to black. And then we're going to highlight the Big Mac column, the large fries column, and the large Coke column. So the red is our antecedent. The blue is going to be our consequent. And we're not going to buy a bunch of them. We're just going to buy one of them, right? One of these is the consequent. And then our antecedent is the red. How do we find the antecedent? We're going to use the sum product, because what we want to do is we want to multiply the 0 times the 1 times the 1. In that first row, that's going to be 0, right? In the second row, we're going to have 0 because in the second row, we have a 0. In the third row, we're going to have 0, right? Because they're all 3 0. The fourth, we're going to have 0. The fifth, we're going to have 0. Do we have any ones? All the way across. Here we go. We got a 1 there, a 1 there, and a 1 there. So we know the sum product is going to be at least 1, right? We're going to type BM, comma, LF, comma, LC. We're going to multiply the 1s and the 0s in a row, in each row. Then we're going to sum those products, right? And we get a frequency of what? We get a frequency of 4. Of these 50 randomly chosen transactions, there are 4 where the person bought a Big Mac, large fries, and a large Coke. We got to divide that by the sample size. So we're going to count the transaction numbers. So we get a probability of 0.08. So 8% of the transactions had Big Mac meals. Now we're going to calculate the probability of the consequent. So this one's just the equal average. So the first one is chocolate shake. The next one is McFlurry, MC. Now that's going to take a while. There's an easier way to do this. I'm going to go back to equal average. I'm going to replace CS with a thing called indirect. And then I will click on the name of the object below it, the ones and zeros below it. What this is going to do is going to take the average of the object named CS, 0.16. And then I can drag this across, right? So we're taking the average of the ones and zeros below CS. We're taking the average of the ones and zeros below MC. We're taking the average of the ones and zeros below SU for Sunday. We're taking the average of the ones and zeros below AP, apple pie. And then we're taking the average of the ones and zeros below CO, which stands for cookies. So this is my support for the consequent when it's chocolate shake. This is the support for the consequent when it's McFlurry. This is the support of the consequent when it's a sundae. This is the support for the consequent when the consequent is apple pie. And this is the support for the consequent when cookies. So let's go in here and enter the information. If the consequent is chocolate shake, the support of the consequent is what? Let me change these to 4 decimal places. If the consequent is McFlurry, the support for the consequent is that. If the consequent is a sundae, the support for the consequent is that. And if the consequent is apple pie, the support for the consequent is that. If the consequent is cookies, the support is that. Let's just check our work. Right, now we need the support. We're going to copy this right here. And the way I'm going to do this is I'm going to put a comma here, right? The BM, the LF, and the LC are fixed, right? I'm going to use K23 to K72. When I drag this across, the blue, the red, and the purple will stay stationary, but the green will move one column at a time to the right. Okay, so there were 0 transactions where there was a Big Mac meal purchased and a chocolate shake. There were 0 transactions where the Big Mac meal was purchased and a McFlurry was purchased. This part here is the Big Mac meal, right? And this is the dessert. There were 2 transactions involving a Big Mac meal and a dessert, namely sundae. And then there was 1 transaction that involved the Big Mac meal and an apple pie, this being the dessert apple pie. There were 3 transactions with a Big Mac and the dessert being cookies. Now, to convert these frequencies into probabilities, we have to divide this by the count A of transaction number. And then I'll slide this across. So this is the support of the consequent and the antecedent, the Big Mac meal. So the support of the Big Mac meal and the chocolate shake, well, that's 0. It's 0 for the Big Mac meal and the McFlurry. It's not 0 for the Big Mac meal and the sundae. It's 0.0400. It's 0.0200 for the Big Mac meal and the apple pie. And it's 0.42, the support for the cookies and the Big Mac meal is 0.0600. Now we have to calculate the confidence in the lift for each one of these, right? Or this is the confidence, and this is the lift, right? Okay, to do the confidence, you take the probability of C and A, and you divide by the probability of A. I'm going to make this easier on me. Now we have the confidence. It's the probability of the consequent and the antecedent divided by the probability of the antecedent. I'm going to change that to 4 decimal places. And I'm going to drag it across. So as I drag it across, it's making this ratio, right? These probabilities range from 0 to 1. The lift is not a probability. We find it by taking this value and divide it by the product of these 2 things. Or another way to say that is we take the conditional probability, the confidence, and divide by the other marginal probability. In this case, probability of the consequent. I'm going to divide the confidence by the probability of the consequent. And then we'll add 4 decimal places here. The confidence and the lift for chocolate shake and the Big Mac meal, those are both 0. Same thing for McFlurry and the Big Mac meal. For the sundae, we have a confidence of 0.5 and a lift of 1.5625. So Big Mac meals, in my random sample, Big Mac meals, large Big Mac meals, and sundaes are complements. People buy them together. What about the apple pie? The confidence is 0.25 for the apple pie and the Big Mac meal. The lift is less than 1. So what that means is when people go in to buy a Big Mac meal, they're not going in to buy an apple pie. For the cookies, the confidence is 0.7500 and the lift is 1.7857. If the random customer adds a dessert to his meal, it will most likely be what? Well, the cookies, because the lift is the highest. Now your answers will vary, right? You got to pick the one with the highest lift. So if the one with the highest lift is apple pie, then of course you'd pick apple pie here.